Students, today we will be studying about the electronic configurations of elements and the periodic table, which is part 3 video of chapter number 3, classifications of elements and periodicity. So as we all know that in the long form of modern periodic table, the elements are arranged in the increasing order of the atomic number, and the periodic table has periods and groups. So those depend upon the electronic configuration. That means the electronic configuration plays a very important role in the formation of the modern periodic table. So by looking at the electronic configuration, we can easily arrange the electrons in different periods and groups. So the period indicates the value of n. So here n, if you remember, n is the principal quantum number, so they represent the value of n for the outermost or valence shell. Okay, so whenever so this is about the electronic configuration in period. Okay, so in the period indicates the value of n. N is a principal quantum number. Okay, so what happens? The highest value of the principal quantum number, which is n, it determines the period of an element, that in which period an element has to be. So element in a period have same numbers of atomic orbitals. Like for example, if we take hydrogen has 1s1. So here the highest value of hydrogen is 1, so that's why it's in the first period. But if we take an example of nitrogen, so the this configuration would be 1s2, 2s2 and 2p3. So here the highest value of n is 2, that is why it is in period 2. Okay, so before this, maybe in your second chapter you will be learning about the structure of atom, and there you will be learning about the Aufbau principle and the electronic configuration, but you have not studied that chapter yet, so it's a little difficult for you to understand. So I will be telling you a little idea about the electronic configuration once again. So actually the electronic configuration is written like 1s2, then 2s2, then 2p6, then 3s2, then 3p6, then 4s2, then 3d10, 4p6, 5s. Okay, and it will be so long. It could be then 6s, then 4f, then 5d. So like then 5s, after 5s it would be 4d, then 5p, then 6s, and so on. Okay, so this is the electronic configuration, which you don't need to learn this. So there's a technique to find out. Like you will write all these like shells. So this is the order in which the orbitals are filled. So all these are the subshells. Okay, so electron enters the orbital, and then in the orbital there are subshells. So all these are the subshells. So how the filling of the subshell is done in a manner that, so according to the it is just done according to the Aufbau principle, which means that in any ground state of an atom, then electron enters the orbital of the lowest energy first, and the other electrons are filled in the order of their increasing energy. So that means the the electron which have the lowest energy will be entering first, will be filling first, and the electrons having the high energy will be filling at last. So this is the Aufbau principle. So the filling of the subshell is done in a manner like you can also write the subshells in here. This is the electronic configuration, which is the filling of the subshells. All these are the subshells. So you can also write like this: 1s, and then 2s, 3s, 4s, even 5s. Okay, so in the first shell there are 2 electrons. Okay, then after this it's 2p here, 3p6 and 4p6. So since it will be 8 electrons, so 2 plus 6, 8. Okay, so in the third period it will be 3d10 and 4d10 and then 4f. We can also write other also, but I think this is sufficient, so I'm not writing. It could be 5p6, then 5d10 and 5f14 also. So first we will arrange like this. So first it will come this way, then again up, and then it will come like this, and then again this, and like this. Okay, so if you'll see, so first is 1s2, so here's 1s2, then we'll come to second, it's 2s2. Okay, so the filling will be done like first the electron will be filled in this shell, and after the both electrons are filled, then it will move to the second subshell, and after they are filled, then it will move to the third subshell, and then this. So this then 2p6, then 3s2 here, and then 3p6 here, and then 4s2, this is here, then coming to the 3d10, it's here, and 4p6 this, and 5s2 this. Okay, so this is how it is done, and then it will be 4d10. Okay, then again it will be if we'll write here, it will be 5p6. Okay, so it will be like this, then again it will be 6. Okay, so I hope it's clear. So this is what you will be doing in your class, in your chapter number 2. Okay, so now let's see the configuration, how the configuration is done. So if I'll show you the configuration in a book which I'm having, so here in this we have periods like period 1, period 2, period 3, period 4. So if you look to the configuration, it's here, it's 1s1 and 1s2. So it has only one shell, so it's 1, so that is from the period number 1. So in period 2, all the electrons that elements in a period have the same number of atomic orbitals. So the elements in one period will have the same number of atomic orbitals. That means that in period number 2, all the elements will be having the number of same atomic orbitals. That means they will be having same orbital, like it's 2s here and then 2p. So everyone will be in the same atomic orbital. Okay, so in period 3 also, so it is from the same period, it is because it's 2 and 2s2 and 2p. So everyone will be from 2. So that's why they are from period number 2. So it's the value of n is 2 here. Okay, so now we'll take an example that here the hydrogen, the maximum value of n is 1, so it's from first period, and it's s1, so it has 1 electron. It has now 1, and the value of n is 1, so it's from first period. Now the value of n is 2 here, so that means they belongs to period 2. So if we see here, all these elements in this period 2, they have the maximum value of n is 3. So that's why they belong to period 3. And in period 4, all the elements have the maximum value of n as the like here although we see it's 3d also and 4s also, but we have to check the maximum the value of n in s orbital. So in the s orbital it's 4, so that's why s from the group number 4, and here the value of the s orbital is 5. The maximum value of n is 5s, so we will consider this value. Okay, so we will always consider the value of s. Now here it's 6s, so it's from period 6. So here you can see there is an increase in the number of electrons in every ascending element. So like here it was 1 and 2. So we know that the atomic number of hydrogen is 1 and helium is 2. Then here it's 2 plus 1. So 2 and 1, it's 3 lithium, and then 2s2. Here of like beryllium, it has to be 2s2 and also 1s2. So that's why it will be 1s2 and 2s2. Okay, so 1s2 you have to assume that it has to be 1s2 everywhere. So like here also 2s2 is missing, because then the configuration will be very long. So that are the common terms, so which have been removed from here. Okay, so it will be 1s2 plus 2s2 plus 2p1, so it will be 5, and so on. It will be like this. So here in the last subshell we see that it's 1 2 3. So every in the every subshell the number of electrons are increasing. Okay, so after this will be, because here the maximum number of electron in 2p subshell is 6. So after it will be completely filled, then the electron will move to the next subshell. So it will enter the 3s1 subshell. Now why it will enter to 3s1 subshell, that I've explained you here, because this is the electronic configuration which will be followed, and also the number of electrons. So again, in a shortcut I will explain you, like example, if we take the configuration of fluorine. Okay, so atomic number is 9 and fluorine, so it will be 1s2 configuration, then 2s2, then 2p5. Okay, so it is like 2 plus 2 4 and 5, it is 9. So in this, how the filling is done, so in this the p, so this we know already, it will be like this. For 1s it will be 1s like this, and then for 2 it will be, accommodation will be maximum 2 electrons, and for this 2p5 it will be having 3 blocks. Okay, so like this. So the filling will be done like the first this and this. So this is how the filling will be done. So once it will be completely filled, then only so like for the neon it will be completely filled, and for the sodium again it will move to the next block. So again it will be having 1 electron. So this is how the electronic configuration is done in the periods. The next, which is electronic configuration in group. Just now we have read about the electronic configuration in the periods, and the elements in a period have the same number of atomic orbitals. That means in a period the value of n will be same. So that is why all the elements having the same value of n will be arranged in one period. But in the groups, the elements which are placed in a same group have the same number of valence electron in the outermost shell. Like if you'll see in this first group, which is alkali metal, so all of these will be having same number of valence electron in their outermost shell. Like here if you see that, but hydrogen is an exception. Hydrogen is, though it's written on the top of the first group, but it is not the part of the first group. Hydrogen resembles the property of alkali metal. Also it represents the property of the property of halogens. Okay, so it sometimes behaves as metal and sometimes as non-metals. So it is a little exception here. So if you'll see from here, from lithium, so the number of electrons in its valence shell is 1, and here also is s1, and here also is s1. And also in this second group we see that the number of valence electron in the outermost shell, which is s2, it's 2, and again it's 2 2 2. So all of these are same. So the elements which are arranged in one group have the similar number of valence electron in the outermost shell. So if you'll see here, so both of these group number 1 and group number 2, both of them have the same s orbital. Okay, so it's also s. So all of these have s orbital as their the last orbital. So that's why they are called as s block element. Okay, so if we'll see here in this D block element, so the D block element comprises of group number 3 to group number 12 here. Okay, So here also the number of valence shell in the outermost shell is 1 and here is 2, so it's like same. Okay, so now we know that it's 3D. So because it's group number 3 here, and we see here that it is period number 4, because the period, the value of n will be considered at s. So the n is the principal quantum number. So this is the this is 4s, so we will consider the s will be the outermost shell. So this is 4, that's why it's 4 period. But here we see 3d1 and 4s2, but it is not because this is s, so it is for sure you will be thinking that why it is not in S block, why these are in D block, because when the filling is done, so the filling will be done firstly to this and then to D, because it is done in the order of Aufbau principle. Like the electron will be having the higher energy, will be placed at the last, so D will be having high energy, that's why it is the last shell. So that's why it's 3, group number 3. Okay, that's all these elements are arranged in group number 3. So it's 3d1, 4d1, so all of them are having the same number of valence electron in the outermost shell, and same in here also. So every where it will be same. So now coming to the 13th group to 18th group, which is p block element, so they will be having the same number of electrons in the outermost shell. So this is the trend in the group. So after this, we will be doing the electronic configuration and types of elements in SPD and F blocks. Okay, so yes, in the first we'll study about the S block elements and their general electronic configuration. Okay, so the division of elements are done into the 4 blocks. Okay, so first we will study about the S block element. S block element. So in this S block element, the elements in which the last electron, I'll write the elements in which the last electron enters the s orbital of their outermost shell, outermost energy level is called is S block element. Okay, so S block element here, the element in which the last electron enters the s orbital of the outermost energy level is called as S block elements. So all the elements in the S block elements will be having s orbital as their outermost energy level. So the outermost energy level will be S for the S block elements. So if we see once again here also in this, so the last orbital is S. Okay, so these are the S block elements. Okay, so some main general characteristics of these are: number 1, it has a general electronic configuration, which is very important. Electronic configuration is NS1 to 2. That means the elements will be in this group will be from 1 to 2. Okay, it also means that the number of electron increasing in this group. So this is the general electronic configuration GEC of the S block elements. Now some general characteristics. So some general characteristics of the S block elements. That means Number one, that all these elements are soft metals which have a low melting and boiling point. Okay, so all these have low melting and boiling point. Then they have low ionization enthalpies. So what is enthalpy? Actually, enthalpy is the thermodynamic quantity which is equivalent to the total heat content of a system, and it is equal to the internal energy of the system. Like, so enthalpy, if I'll explain you enthalpy here, enthalpy, okay, so it is so the symbol of enthalpy is H, and it is equal to the E plus PV, where E is internal energy and this P and V is the product of pressure, because it's B and V, to it's product of pressure and volume. So this is enthalpy. So it is the sum of the internal energy and the product of the pressure and volume. So it's a thermodynamic quantity. Okay, so these we will be learning about enthalpy in this chapter after this topic. So they have low ionization enthalpies. Okay, so now that's very common that they are very reactive, and they are ready to form alkali metals and alkaline all these they are very reactive forms of ions, and they just lose their electrons, 1 or 2 electrons in their valence shell. So both group number 1 and group number 2 are very reactive, and they are so reactive that they react almost with everything, and that's why they are never found in their pure nature, and they impart a color. Okay, so number 3 is they are very reactive, and they donate 1 or 2 electrons, very readily, and then they impart a characteristic color when they are burned. So they impart color to the flame. After this, we'll move to the p block element. Second, p block element. Okay, so these p block elements are those elements in which the last electron enters the p orbital of the outermost energy level. So the last electron enters p orbital of their outermost energy level. So these are the p block elements. I hope it's clear. So the general electronic configuration for the p block is NS2 NP126. Okay, so this is the general electronic configuration, where this 1 to 6 is the at the increasing number of electrons in the groups, because it has from group number 13. It is from group number 13 to group number 18. Yes. Okay, so from group number 13 to 18, and everywhere, like if I'll explain you here the general formula why we write this. So it is like NS2, it will be there, and then it will be NP1, and then one electron will increase and it will become ns2, and then it will become np2, then ns2, np3, and it will increase the number. The electron will be increasing by one number, so from 1 to 6. Okay, so that's why the general electronic configuration is ns2 np1 to 6. Okay, so the general characteristics of p block elements are that they includes both metals and non-metals. So generally they are non-metals, but some of them are also metals, so they include both metal and non-metals. They include both metals and non-metals. Okay, then when we move from left to right in this block, we see that the metallic character goes from the metallic to the non-metallic, and the metallic character of these increases when we go down the group, and the non-metallic character decreases when we go down the group. Okay, and then the ionization enthalpies of these group, like of these block of p block, is relatively high as compared to the s block element, because the s block element were having low ionization enthalpy, but these group like p block will be having the ionization enthalpies are high than S block elements. Okay, so the third will be they mostly form covalent bond, because they are non-metals. They mostly form, so they will not donate the electron, they will either gain the electron or they will form the covalent bond among themselves. Then some of them show more than one oxidation state in their compound. That means they oxidize, but sometimes they forms metallic oxide and sometimes non-metallic oxides. Example, aluminium. Aluminium is amphoteric in nature, so we all know about that. So now they occur in a gradation from reducing to oxidizing property as we move across the period. So now like the 13th group of this period will be more towards metals, because they're metals, so they will be forming metallic oxide. But when we move from the side, from left to right to this block, we'll see that they will become non-metallic oxides. Okay, so all these elements in this there is one group in this p block element. So group number 18, which is an important thing to note, or to note down, that the element of the last group is having ns2np6 configuration, and this is called as the noble gas. So this noble gas has a unique property that in this all the valence shells are completely filled and they don't have any tendency to lose or to gain the electrons. Okay, so therefore the noble gas exhibit a very low reactivity, so which is an thing, because we have just studied about that all the elements are either metals or non-metals, but and they are very highly reactive also, like the non-metals are reactive, but the last group, which is 18th group, is non-reactive because they are of noble gases. And before this 18th, the group number 17, group 17 is called as halogens, which is a very reactive group. That means all of them will be having one electron in the outermost shell, because the general the electronic configurations of halogen is ns2 np, it is 5. So because it's 5, but it will require 1 electron to complete its shell, energy shell. So it wants to be like this noble gas, but it accepts 1 electron, so that's why it's quite reactive. So these halogens and the group number 16 is called as calogens. It's chalcogens, actually it's chalcogens. So it's group number 16. So these two groups can readily accept 1 or 2 electrons, and they want to attain the electronic configuration of their noble gas. Okay, so that's why these two groups, which is group number 16 and 17, are also very highly reactive. Then moving to the D block, the third is D block elements. So the elements in D block are the last the last electron enters the d orbital. Okay, but in this D block element, in this D block elements, the elements in which the last electron enters the d orbital. The d orbital at last, but only one will be there, but one energy level constitute. Okay, so what happens in this D block element? It lies between S and P block elements. So it starts from the fourth period, for the fourth period onwards, and it is from the third group to the 12th group. Okay, so all these elements which comes from the third group to the 12th group. So what happens in these elements? The outermost shell contain 1 or 2 electrons in their s orbital, but because the filling is done, like the electrons with the high energy level will be filled as last. So in this, the energy level will be filled at last, so like it will be filling like at 2s2. So after this, example of zinc, not 2s2, but it will be 4s2. I'll draw once again. So it will be 3d 4s2. Okay, so in zinc it will be 10d. So first it will enter here, and after it will be completely filled, then it will enter to this. So this is the last filled. So that's why it's called as D block. So when the filling is done, the last electron will enter to whichever shell will call as that group. That's why they are called as D block element. Okay. The general formula of the D block element, the general electronic configuration of the D block element is n-1 D1 to 10 ns0 to 2. Here n is the principal quantum number and d is the subshell, and 1 to 10 denotes the number of electrons which will increase, because they will be the elements from group number 3 to group number 12. And here ns, so ns means it is the last shell, but again after this it's a d, so the filling will be done to the d to the last, although it's the last shell is s here, but after this the electrons will be filled in this, then it will move to d, because it will be having a higher energy. So according to Aufbau principle, the electrons are filled in the according to their energy levels. So the electrons having low energy will be filled first, and the electrons will be having high energy will be filled, high energy orbitals will be filled at last. So it will be 0 to 2. Okay, this is the general electronic configuration of d block elements. Also, this d block element have some special features, like they act as a bridge between the chemically active metals of s block element. Like you know that it's S, then it's P here, and it's a D. It acts like a bridge to the S and P block element, as they show a transition. Okay, so d orbital is filled with the elements which shows the transitions. That means they are called as transition elements, because the property of these elements, of these d block elements, are midway. That means these are metals and these are non-metals. So generally these are also metals, but they will change their property from metals to the non-metals. Okay, so as the properties of these elements is changing from S block to the P block, that's why they act as a bridge between the chemically active metals of S block and of the P block. So like this is the group number 1 and 2. So this is from 3 to 12 and from 13 to 18 here. 18 is the noble gas group. So these from 3 to 12 groups. So these elements are, even 13 group also are metals, and after that they change their behavior and they show a transition. That means a change in their behavior. That's why they are called as a transition elements. So d block elements, they comprises 3 complete rows. That is the first row, the first transition series. Okay, so the first transition series is of the 4th period, example scandium. Okay, so like for scandium, so scandium from atomic numbers, atomic number is denoted by Z. So from 21 to zinc, which is atomic number 30. Okay, so in this first transition series, it belongs to the 4th period. Okay, so in this the 3d orbital is gradually filled, are gradually filled. Okay, then the second transition series, it starts from the yttrium. Okay, so atomic number 39, and it moves to the cadmium, atomic number 48. Okay, so this is for the 5th period, and 4d orbital are gradually filled. Then the third transition series, which is lanthanum, atomic number 57, to hafnium. Okay, atomic number 72. Even to the mercury 80, atomic number 80. Okay, so they are from the 6th period, and 5d orbital will be gradually filled. Okay, then again we have 4th transition series also of actinium, because in the periodic table you would have seen a star mark also. So in the actinium, atomic number from 89 to rutherfordium 104, and to coperincium it 112. It is in the 7th period. So the 6th orbital is gradually filled. Okay, so the general characteristics of this d block elements. the general characteristics of D block elements are, that means they are metals having a very high melting points. Okay, so these are generally metals, and they have metals having high melting and boiling points. Okay, and most of them again they form a colored compound. Okay, and then they also have a tendency to form complex compound, and these compounds are generally a little magnetic, and they also exhibits the oxidation states. And most of the elements, these are transition elements. Most of these are transition elements, such as manganese, nickel, cobalt, krypton, etc., and they are used as catalyst and are used as catalyst. So catalysts are the compounds which increases the speed of a chemical reactions. Okay, so these are the substances which do not react with the which do not take part in the chemical reaction, but they increases the speed of the reaction. They don't ignite the reaction, but they increases the speed of the reaction. Okay, so after this we come to the F block, the last block or the fourth block, F block element. F block element. So these F block element are those elements in which the last electrons enters the f orbital. The last electron enters the f orbital. Okay, so these have again two different series, which is of first is these have two series of elements, which is number one is the lanthanide series, lanthanide, and the other one is actinoids. Okay, so lanthanides are also called as the rare earth metal, and they are from atomic number 57 to atomic number like 71. Okay, and then the actinium or the actinoid series, which are from atomic number Z equals to 89 to 103, and these actinoids are generally the radioactive elements. That means they are radioactive in nature. Okay, so actinoids or actinides are the radioactive elements which emits the radioactive rays. So the general formula, general electronic configuration okay is N-2 F1 to 14 and N-1 D0 to 2 NS2. So it's a very long electronic configuration, which means that here N-1 will be there. So N is, I hope all of you remember, I have been saying you again and again, it's principal quantum number. So the value of N is -2, Okay, then F, it's from the F orbital, F block, so it's of F from 1 to 14 elements. Okay, so like electronic configuration, the number of electrons will increase from 1 to 14, and then N minus 1 again, and D, it's 0 to 2. Here, if we take the example of lanthanoids, so the general electronic configuration of lanthanoids will be 4 F1 to 14, and then 5 D0 to 1, and 6 S2. That means it could vary from 1 to 14, the number of increasing electrons, and for D suborbital it would be 0 to 1, and then it's for the 6s subshell it's 2 electrons. So it's for lanthanoids, and for actinoid it could be 5f1 to 14 and 6d0 to 2, and it's 7s2. So this is the general electronic configuration. Now these elements also includes two series, as we know, and these are called as inner transition elements. So they will also show transition because they form transition series. In this, the transition elements of the D block, because they are a part of a D block, and these are also called as the transition elements. So they are a part of a D block, but they are out of that because they are so many elements, so they cannot completely fill to the D block. So at the last, we will do the general characteristics of the F block's elements. Characteristics. So they are heavy metals. They all are heavy metals, and they have high melting and boiling points. So then they also form colored iron. They exhibit the variable oxidation states, and they have tendency to form complex compounds. Now actinoids, in this, the actinoids are really special. It is an important property that actinoids are radioactive in nature. So these are radioactive in nature, and many actinoid elements have been made only in the nanogram quantities, because or even less by nuclear reactions, and in their chemistry is not fully studied. Okay, so elements after uranium are called as transuranium elements. So uranium is one of the element of these actinoid series, and uranium. So after uranium, because they have not been studied, so all the elements after uranium are called as transuranium elements. Okay, so on these basis of all the 4 blocks, the elements can be classified into 4 general types. That is, the classification can be done into 4 types, which is noble gases, and the representative elements of S and P block, then transition elements, and the inner transition elements. Okay, so and these, the noble gases, are the gases of group number 18. Group S block are those elements which starts from 1 to 2 and from 13 to 18. Okay, or even 17 will do, because we have only. Then transition elements are from group number 3 to group number 12, and these are the elements which are the inner transition elements which are into this, and these are F block, and these comprises of 2 series of 14 elements called as lanthanides and actinoids. So with this we complete this topic. So in the next lecture video we'll study about other topics. Thank you.